So now that we have defined a trig function for an acute angle, so an angle in quadrant 1, we're going to look at the definition of a trig function of any angle. So whether it lands on quadrant 2, in quadrant 3, in quadrant 4, or on an axis angle. So we have a definition. Let theta be an angle in standard position, and x comma y is a point on the terminal side. So you can see the diagram of that. So here's a little diagram. This is your terminal ray. You have your angle right here. It's in counterclockwise. And x comma y is just any point on the terminal ray. And there will be infinite amount of options for that because the ray extends indefinitely. And you let r be the distance from the origin to the point. So the further the point is on the line, the bigger r will be. The closer the point is to the origin, the smaller r would be. And how you define the 6 trig functions, so here are your definitions again, are going to be that the sine of theta is going to be the y coordinate over r. The cosine of theta will be the x coordinate over r. The tangent of theta will be the y over the x, as long as x is not 0. Now, r will never be 0 because it's the distance from the origin, so it has to be greater than 0. It has to be positive. Let's actually add that in the definition. Now, the other 3 trig functions will follow from our identities. So secant is going to be the reciprocal of cosine, cosecant will be the reciprocal of sine, and cotangent will be the reciprocal of tangent. So really what you want to focus on are going to be, actually let me make this a little bit lighter, it's going to be these 3 here. So let's do a problem. Find the exact values of the 6 trig functions of theta, given that 4 comma negative 3 is a point on the terminal ray. Okay, so we draw a visual. Always draw a visual in this class, almost always. So you have 1, 2, 3, 4, 1, 2, 3. So here's my point. So that means that I have gone 4 to the right and 3 down. So this is 4 and this is negative 3. So here is my r. So this creates, the 4 and the negative 3 create a right angle. So r is going to be the hypotenuse of the triangle. So I have that r squared is equal to 4 squared plus negative 3 squared. Remember to put the negative in parentheses because anytime you square a negative, it becomes a positive. So r squared is equal to 16 plus 9. R squared is equal to 25, which means that r is 5. Nice. Works out great. Again, r has to be positive because it's the distance from the origin. So it's a distance. So let's begin with our 3 main trig functions. So the sine is going to be the y coordinate over r. The cosine is going to be the x coordinate over r. And the tangent is going to be the y over the x. And as long as we know those, then the other ones can follow. So cosecant will be the reciprocal of sine, so 5 over negative 3. The secant will be the reciprocal of cosine, 5 over 4. And the tangent will be the reciprocal of cotangent, negative 4/3. And here are your 6 trig functions. So what I want you to remember really, and I'm going to put a little star here, is that the sine is associated to the y, and the cosine is associated to the x. It's going to be very useful as we move forward. Okay, so now that we have created this definition, we can evaluate our missing 4 golden angles. So we have done 30, 45, and 60, and now we can do 0, 90, 180, and 270. And we do them very all similarly. So I'm going to begin with 0 degrees. So the way that we do that is, this is 0. We're going to pick a point on the terminal ray. So if this is 0 degrees, you pick any point, but I'm going to pick as small as possible. I'm going to pick 1, 0. Remember that when you go to the right, the x changes. So if this is 1, 0, the distance from the origin is 1 because y hasn't moved at all. So this is r. And this is x, and this is y. So then you can create your 6 trig functions. So the sine of 0 degrees is the y over the r. So 0 over 1 is 0. The cosine of 0 degrees is x over r. So 1 over 1 is 1. The tangent of 0 is y over x, so 0 over 1, which is again 0. And then we can take the reciprocal. So the cosecant of 0 is the reciprocal of sine. And so we're going to get 1 over 0. But anytime you get 0 in the denominator, it's undefined. Then we have the secant of 0 is going to be the reciprocal of 1. 1 over 1 is still 1. And the cotangent of 0 is going to be 1 over 0, which is again undefined. So cosecant and cotangent are undefined here. Okay, let's do 90 degrees. So this is 90. So I'm going to pick the point. Now I'm going to go up 1. So it's going to be 0, 1. R is still going to be 1. So R is still 1. This is x and this is y. So now x and y have switched. When I do 180, this is going to be 180. So when I pick my point, I'm going to go left, which means that x is going to be a negative 1 comma 0. So this is x, this is y, and r will be 1. And then when I go to 270, I'm going to go down. I'm going to pick my point. This is going to be 0, negative 1. So r will still be 1. And this is x, and this is y. So then we can fill them in. So I have the sine of 90 degrees is going to be 1 over 1, which is going to be 1. The cosine of 90 degrees will be 0 over 1, which will be 0. The tangent of 90 degrees is going to be y over x, 1 over 0. That's going to be undefined, 1 over 0. Let me write it first, just to. The cosecant of 90 degrees, well, the reciprocal of 1 is 1. The secant of 90, the reciprocal of 0 is undefined because 0 goes in the bottom. And the cotangent of 90, well, the reciprocal of 1 over 0 is 0 over 1, which gives me 0. So now it's tangent and secant that's undefined. Okay, let's do the next one. The sine of 180 degrees, 0 over 1 is 0. The cosine of 180 degrees, negative 1 over 1 is a negative 1. So be careful now because the negative is there. The tangent of 180 degrees is going to be y over x. So 0 over negative 1 is 0. The cosecant of 180, the reciprocal of 0 is undefined. The secant of 180, the reciprocal of a negative 1 is negative 1. Now remember, the negative has to come with you in the reciprocal. It doesn't become positive. And the cotangent of 180 degrees, negative 1 over 0, the reciprocal of tangent, is going to be undefined. So again, in this one, cosecant and cotangent are undefined. Let's do the last one. The sine of 270, or 3 pi over 2, negative 1 over 1 will be negative 1. The cosine of 270 degrees, it will be 0. The tangent of 270 degrees will be negative 1 over 0, which will be undefined. The cosecant of 270, the reciprocal of sine, will be a negative 1. The secant of 270 degrees, the reciprocal of cosine, will be undefined. And the cotangent of 270 degrees will be 0 over negative 1, which will be 0. So again, now this time, tangent and secant are undefined. And we'll discuss this later, but actually cosecant and cotangent are always undefined together, and tangent and secant are always undefined together. So as we discussed in the last one, right, what's important here is that you really remember your sine, cosine, and tangent. And then the rest will follow. But the key is also to draw your diagram, right? Have your little diagrams. So let's see. Let's put everything together about all of our golden angles. So now we have the 6 trig functions of 0, 30, 45, 60, 90, 180, and 270. So for the axis angles, you draw this kind of visuals. For 30, 45, and 60, you draw triangles. Okay, so we want to find the exact value. Well, here's our favorite kind of instruction, right? We want to evaluate, we want to get a numerical value. So we want to evaluate the sine of 390. Now, 390 degrees is too big because it's bigger than 360. So what we're going to do is we're going to find the coterminal angle. So we're going to subtract 360 degrees from it. Coterminal. So we're going to get the sine of 30 degrees. Okay, to help me with that, I'm going to draw my little visual. This was 60, this was 30, this was 1, this was 2, because I cut my equilateral triangle in half. And by the Pythagorean theorem, this was square root of 3. So sine is opposite over hypotenuse. So the sine of 30, oops, I said opposite and I highlighted adjacent. So let's go back. Opposite is 1, 2, because I'm working with 30 degrees. So the adjacent is 1 over 2. Okay, let's look at the next one. I have the tangent of negative pi over 2. This is negative. That's bad. So what I want is I want to do the coterminal. I want to find the positive version of it. So I'm going to add 2 pi. Now, to do negative pi over 2 plus 2 pi, I need a common denominator. So negative pi over 2 plus, I'm going to change it to a denominator of 2 and multiply the top by 2, which will give me 3 pi over 2. So I have the tangent of 3 pi over 2. Again, if you're starting to get comfortable with your radians, it is 270, 3 times 90. So I'm going to draw my little diagram. Now, for axis angles, the diagram is this diagram. Here it is. I have my point here, 0, comma, negative 1. R is 1. So tangent is y over x, which will be negative 1 over 0. So it will be undefined. It doesn't exist. It is literally not defined. Next one. The secant of 420. Again, too big. Let's subtract 360. So I have the secant of 60 degrees. I'm going to draw my triangle again. This was 60. This was 30. This was 1. This was 2. By the Pythagorean theorem, this was the square root of 3. So what I'm going to do to help me think about it is first I'm going to find the cosine of 60, and then I'm going to take the reciprocal. So the cosine of 60, which is here, is adjacent over hypotenuse. So it's going to be 1 over 2. And so the secant is going to be the reciprocal of cosine, so it's going to be 2. Okay, next one. Okay, it's negative. I don't want that, so I'm going to add 2 pi. Again, on the side, negative 7 pi over 4 plus 2 pi is equal to negative 7 pi over 4 plus over 4. So I need to multiply the top by 4, which will give me 8 pi. This will give me 8 pi over 4. So I have the cosecant of pi over 4, which is equal to the cosecant of 45 degrees. So I'm going to draw my triangle. This was 45. This was 45. This was 1. This was 1. This was the square root of 2. So what I'm going to do is I'm going to find the secant of 45 degrees. I'm sorry, not the secant, the sine. And then I'm going to take the reciprocal. So sine is opposite over hypotenuse if I'm looking at this 45 degrees here, but they will both give you the same. So that's 1 over the square root of 2. So when I take the reciprocal, it's going to be the square root of 2. Okay, let's do another one. Cotangent of 5 pi. Again, this is too big. It's much bigger than 0 to 2 pi, 0 to 360. So I'm going to subtract 2 pi. So 5 pi minus 2 pi is 3 pi. That's still too big. I'm going to subtract 2 pi, which will give me pi. Okay, now that's between 0 to 360. So I'm looking for the cotangent of pi, which is the cotangent of 180 degrees. So I'm going to draw my diagram. Remember, for the axis angles, the diagram is this one. So I have negative 1 comma 0. R is equal to 1. So I can find the tangent of 180, which is y over x, 0 over negative 1. And then when I take the reciprocal, that's going to be negative 1 over 0, which is going to be undefined. All right, last one. Again, this is negative. So I'm going to make it positive, plus 360. It's going to be the cosine of 45 degrees. I'm going to draw my triangle. As you notice, I'm not looking up. I know I already drew it, but that's not how I'm going to learn. I'm going to learn by doing that repetitiveness of having to draw it a lot. So this is 1, this is 1, this is square root of 2. So if I look at this 45 degrees, cosine is adjacent over hypotenuse. So that's going to give me 1 over the square root of 2, or rationalized radical 2 over 2. Here's my final answer. So here are all of them. If you take a look, I drew a diagram for every single one of them.